Okay, welcome to my second class, and this is on division. My name is Vishal Bhatia. I've done a master's in finance from the London School of Economics, and I did a BA in economics from Shriram College of Commerce. So basically, there are several specific methods to handle Vedic division. Like, for example, if you're dividing by 5 to the power of n, 5 to the power of 1 is, just one second. Can everybody see my screen, please? Okay. So 5 to the power of 1 being 5 to the power of n being 5 division by 25 division by 125 division by 625 and so on and so forth. I'm not handling all those because that's like, very, very easy to handle. Now, as a Vedic, practitioner, I also have a difficult time in conceptualizing how Vedic division goes about. So let's begin the presentation for today, and I'll take you through the 4 steps. First, let's look at the division basics. First of all, you must remember that division is nothing but the reverse process of multiplication. It is nothing but repeated subtraction. Now, when we talk about multiplication, it's repeated addition. So, because division is the opposite process of, is the opposite process of multiplication, in division, what we do is we do repeated subtraction. So, when I say that I'm dividing 9 by 3, this actually is nothing but 9 minus 3, we get 6. 6 is further, we subtract 3 from 6, we get a 3, and then we do another subtraction from 3 till we are left with a remainder called 0. That's all we do over here in division. This is the division sign which is you use in school mathematics. It's called an obolus, and the plural is oboli. Same thing as abacus and abaci. Now on a computer keyboard, you will find a forward slash which is used for division. This is called a virgule or a solidus. Vedic division is all about the base method. So under multiplication, if you've done the base method, division actually becomes a lot easy to understand. There are chiefly 4 methods in Vedic division. The first method is the Nikhilam method, and Nikhilam is Sanskrit for base. Now, as you already know that the bases in Vedic maths are 10, 100, 1000, or 10 to the power of any positive integer like 1, 2, 3, 4, 5, 6. When do we use this method? We use this method when the divisor is less than the base and close to the base. For example, if the divisor is 99, 998, 867, we use the Nikhilam method. Then the second method that we use is the transpose method. I think it's called the yoja paravartya method. I'm not very good at all these Sanskrit terms. When do we use it? When the divisor is greater than the base, and please bear in mind that the divisor begins with a 1. This is extremely, extremely important. So 189, 1001, 1234. But supposing we have to divide by 201. We will not use this method or this method. What we will instead do is either multiply 201 by 4 and scale up the divisor to 804, or we multiply 201 by 5 and scale it up to 1005. And if you notice, we get a 1 in the beginning, and then we will use the transpose method.
From minus 16.7 అన్నాడుగా
minus 15 points దాంట్లో నుంచి
ఏం తీసేస్తే
Can I take the questions later at the end of the presentation, please?
Okay.
The third method is the ratio method, Anurupena method. This is when the divisor is not close to any base. Remember, in this case, and in this case, the divisor was close to the base. So for example, you have 23, you have 34, you have 425. So what we do in the ratio method is just the divisor, we multiply it by 4, we get 92. And we use method number 1, the Nikhilam method, because this is less than the base. Alternatively, we can also multiply 23 by 5 and take it above the base, and then because the divisor begins with a 1, we drop the divisor and we take the transpose of 1 and transpose of 5, which is 1 bar, 5 bar, and use method number 2, which is the transpose method. Once I explain everything
Sir,
in detail,
excuse
you'll
me,
be able
sir.
to.
Sir, can you explain roughly once from first?
Okay. Nikhilam method is when the divisor is less than the base. Notice this sign. Less than the base and close to the base. So in this case, if the divisor is 99, my base is 100. And my divisor is 99 is less than the base. If it is 998, my base is 1000. And 998 is again less than the base. And it's close to the base. 867 is also relatively close to a base. My base is 1000. My divisor is 867, less than the base. And if you look at a deficit, 9 minus 8, 1, 9 minus 6, 3, and 10 minus 7, 3. I'll come back to this later. Then this is you just have to look at a divisor. In Vedic division, you have to look at a divisor. You have to ignore the dividend. The dividend has no role to play except the separation of the dividend digits into remainder and quotient components. I'll come to that later. When do we use the transpose method? When the divisor is greater than the base, and the very important concept begins with the digit 1. 189 is greater than 100. 1001 is greater than 1000. That's my base. And 1234 is greater than again my base of 1000. And all these are starting with number 1, digit 1, digit 1, digit 1. Very important to remember this. This is not mentioned. See, the problem with Vedic maths division is the books do not cover the basics, the fundamentals. The videos on YouTube also don't cover the fundamentals. And that's why students and the learners of Vedic maths, in fact, even the trainers, they have a hard time. When do we use the ratio method? It's also called the Anurupena method. When the divisor is not close to any base. 23, 34, 425. I can take 23, I can multiply it by 4 times and bring it closer to a base 100. I get 92. And then I will use this method. Alternatively, I can take 23, multiply it by, 5 times, bring it to 115. And now because my divisor is starting with a 1, I will use this transpose method. We'll come to that, very soon. We'll, finish it off very quickly. Finally, we have something called the Vinculum method. By now you must be aware of the fact that Vedic mathematics does not entail the use of 6, 7, 8, and 9. We vinculumize these particular digits in the divisor. And mind you, there is a divisor and there is a dividend. We can vinculumize either the divisor or we can also vinculumize the dividend. Both can be vinculumized. Again, the concept of vinculumizing of the dividend is not mentioned in any Vedic maths textbook or on any YouTube video. Now, when the divisor has digits like 6, 7, 8, 9, we convert them into tens complements. A 9 is nothing but 10 minus 1, so we represent it by a 1 bar. An 8 is nothing but a 2 bar. A 7 is nothing but a 3 bar. And your 6 is nothing but a 4 bar. We don't look at 5. We don't vinculumize 5 because 5 is the same as a 5 bar. So we don't look at this. Only 4 particular digits are converted. And I'm just, when I cover this Vinculum concept, I will also tell you how to handle, how to Vinculamize a normal number. Numbers with digits like 67, 79, 889, 9908. Now, 9908, if you look at it, the base is 10,000. 9 minus 9 is 0. 9 minus 9 is 0. 9 minus 0 is a 9. And 10 minus 8 is a 2. So we can either use the Nikhilam method over here because we can easily handle this, or we can also convert 9908 into a Vinculum form and then proceed further. So we look at these four methods, and most of your concepts, in fact, all your concepts about Vedic division will get very quickly clear. Let's look at the first method, the Nikhilam or the base method. Divisor is less than the base and close to the base. As an example, I've taken 2489 divided by 99. This particular 99 is also called the series of nines. And I'll leave it to Charan to tell you how to divide by 999, 999. These are specific cases, like you had it in multiplication. This is my number 24 by 89. And what's happening over here is that my base over here, just one second. My base is 100. How many zeros does 100 have? 2 zeros. Now, when you have 2 zeros, you separate the divisor into 2 digits on the right side for the remainder and 2 digits on the quotient side, proceeding from right, going all the way to the left side. My base is 100. I've already mentioned this, that my base is 100. We have to look at the divisor. The dividend has no role in Vedic division. The only role that the dividend has is in this separation component. After that, it has no role. My divisor is 99. I find out what is the deficit from my base 100. My deficit is 0, 1. The first step in Vedic division is the dividend's first digit, you drop it as it is. No matter how large the number, how small the number, you just drop it. The second step is I multiply 2 by 0 and I get this particular 0. And since my base has 2 digits, I always consider 2 digits in the deficit. This is don't write it as 1, you'll make a mistake. You write it as 0, 1 because there are 2 digits over here. So the first thing that I've done over here is I multiply 2 by this particular 0, and in the next column, I write this 0. Then what I do is I multiply 2 by this particular 1, and in the next column, I write 2. Now this, my separator should have been shown over here. Subsequently, what I do is I bring down this 2 further, plus 0 to get this particular 4. Separator again over here. Now using this particular digit, I multiply it by 0 and I get this particular 0. And then subsequently, I multiply 4 by this particular 1 and I get this particular 4. Once I have entered the last column, I stop further division or multiplication. My process stops over here. Now what do I do? In the remainder, I have these particular digits and these 2 digits. I sum them up. 8 plus 2 is 10 and 9 plus 4 is 13. And remember that this is in the tens place. So this will get carried forward and added over here. And I'll get a remainder of 113 and a quotient of 24. And just bear in mind, just look at this subscript. Can my remainder be greater than my divisor? No. So what I do is I divide the remainder 113 by my original divisor, which is 99 over here. And then if I divide 113 by 99, I get a quotient of 1 time and I get a remainder of 14. And this particular Q2, I added to get a final quotient of 24 plus 1, 25, and a remainder of 14. Right? Now, let's look at 2489 divided by 98. In the last slide, I had divided it by 99. Charan will tell you about division by series of nines. Same process, I check my base. Base has got 2 zeros, starting from the right side, proceeding towards the left side. I split up my remainder into 2 digits, and the remaining digits go into the quotient bound. This is my divisor. What is the deficit from 100? 0, 2. 2 zeros here, 2 digits over here. I drop this 2 as it is 2. I multiply 2 by 0 to get a 0. I multiply 2 by 2 to get this 4. Then I take this 2 down. I sum up 4 plus 0. I get this particular 4. And then with this 4, I again multiply by 0. I get this 0. 4 multiplied by this 2, I get this particular 8. 8 plus 4 is 12. 2 digits, there's only space for 1 digit. 9 plus 8 is a 17. This one is a carry forward. My remainder is 137, which cannot, my remainder is greater than my divisor, which is 98. So I divide my remainder 137 by 98. 98 goes one time into 137 for a Q2 1 and a remainder of 39. And my Q final is Q1 plus my Q2, which gives me a quotient of 25 and a remainder of 30. Right? Okay, proceeding to the transpose method. What is the transpose method? When my divisor is greater than the base and close to the base. And don't forget, I told you that my divisor's first digit is a 1. My base is 100, 2 zeros over here. So I take what is the surplus. Surplus is, I drop the 1, I look at the surplus. Surplus is 02. It's a positive quantity. So I transpose this 02 and I get a 0 bar, 2 bar. Transposing here means positive digits into negative, negative into positives. As usual, I drop the quotient as it is. The first digit is dropped. I get a 2 over here. 2 times 0 bar is actually meaningless. It's a 0. 2 times 2 bar is a 4 bar. Should have put over here. 4 plus 0 is a 4. Then this particular 4 is again multiplied by 0 to get this 0. 4 is multiplied by this negative 2 to get a negative 8. And here my life becomes very easy. When I add up the remainder columns, 8 minus 4 plus 0 is a 4. 9 minus 8 is a 1. This time I am very lucky. My remainder is less than my original divisor of 102. So I don't have Q1s and Q2s to handle. My quotient is a 24 and my remainder is a 41. Let's move to the ratio method. In ratio method, what happens is I get a number like this, whereby, it is not close to any particular base. So what is happening is dividing by 44, but I upscale this 44 to bring it close to a base. So what I do is I multiply the divisor by 2. This is what I've done over here. I brought it close to the base 100. 2 zeros over here, 2 digits over here. My deficit from the base is 12. I drop the first digit of the quotient as it is 2. 2 multiplied by 1 gives this 2. And 2 multiplied by 2 gives me this particular 4. 4 and 2 I add up on the quotient side to get this particular 6. 6 multiplied by 1 is this. 6 multiplied by 2 is this. I've reached the last column. So further multiplication, addition, subtractions, everything ends. I add up these numbers. 8 plus 4, 12 gives me 18. 9 plus 12 gives me 21. This 2 is actually carry forward. 18 plus 2, 201. Now my 201 is greater than my 44. So I divide this further and it gives me a Q2 of 4, a remainder of 5. And believe me that this particular quotient also has to be multiplied by 2 because I did not multiply the dividend. I did not change the dividend over here. So 26 into 2 plus this Q2 4 over here gives me 52 plus 4, 56 as my final quotient and my remainder as 25. This is called the Anurupena method. Okay, the Vinculum method. Turn the divisor into Vinculum form. 2489 divided by 98. I'm not changing the Vinculum over here. In the subsequent slide, I'll show you how I've done that. 98, if you know the Vinculum method, 10 minus 8 is 2 bar and 9 becomes a 10. I have a 1 in the beginning. So I use method number 2, the transpose method now. Again, my base is 100 because 102 bar is close to 100. I drop this 1 and I transpose 02 into positive 02. Drop the quotient as it is 2. 2 times 0 is a 2. 2 times 2 is a positive 4. I add this on the quotient side to get 24. This 2 comes down like as it is, and this 4 and 0, they get added up. 4 times 0 is 0. 4 times 2 is 8. We've reached the last column. Let's sum up. 8 plus 4 is a 12. 9 plus 8 is a 17. Space for one digit, carry forward 137. My remainder is greater than my divisor of this particular divisor, 98. 98 goes one time to 137 with a remainder of 39. So my Q final is this particular quotient here, and this particular quotient over here is a plus 1 to get a quotient of 25 and a remainder of 30. Now, in this particular example, I only did one thing. The divisor was vinculamized. In the next, this thing, I did not have time to prepare the slides. So this time I will show you that I'm turning the divisor and the dividend both into vinculum form. 2489, this is 1 bar. This gets increased by plus 1, becomes 2491. I still have a digit greater than 5, which is 9 over here. 1 bar drops like it is. 10 minus 9 is a 1 bar, and this is 25. So I stop over here. 98, I've already vinculamized it in the last slide. It's a 102 bar. Very simple. Again, same process, moving from rightwards to leftwards. So I have a new dividend over here. Instead of 2489, I've made it into 25, 1 bar, 1 bar. And because 98 is 102 bar, my divisor is beginning with a 1. I drop this 1. I convert this into, I transpose this into 02. I drop the 2 as it is. 2 multiplied by 0 is a 0. Sorry. This one. And 2 multiplied by 2 is a 4. I sum up this 5 plus 0. I get 5 over here. Then this 5 is multiplied by 0. I get a 0 over here. 5 multiplied by 2, I get a 10. 1 bar plus 4. Notice the beauty of Vedic maths. 4 plus 1 bar becomes, 3. And 10 minus 1 becomes a 9. And this remainder is less than my original divisor of 98. So I basically get a quotient of 25 over here and a remainder of. So that was it. Any questions? Anything that you want to ask me?
Sir, so why do
Yes.
why do we use Vinculum method for dividing by 98? We should have used that base method that as well.
See, I will tell you why I did it. In Vedic maths, as they say, there is a saying in in English, the n ways to, skin a cat. Now, what I'm trying to achieve over here is I'm trying to demonstrate the power of Vedic maths. Yes, you can use the Nikhilam method, but handling 98, handling 97, and these kind of numbers with digits greater than what you call it 6 is more difficult. That's why we Vinculamize it. Now I'll give you your answer in a slightly roundabout fashion. For example, I ask you to multiply 98 by 16, or let's say, sorry, 14. I Vinculamize this, I convert this into 102 bar, and I multiply it by 14. Is my life not a lot easier? Because this becomes 8 bar, 0 and 4. I leave this. This is 2 bar, 0 and 1. Right? Sum these ones. 8 bar, 2 bar, 4, 1. 1, 3, 9 minus 2, 7, 10 minus 8, 2. Am I right, Charan? Is this correct? Hello? Hello?
Yes, that's correct.
Okay. So that was it. I wanted to keep this very simple. Before you rush into the Dhwajang system, Charan can teach you the Dhwajang system. He's an expert on that. I would just ask you people to look at the 4 methods. The first method is Nikhilam, or the base method. Divisor is close but less than the base. Second is Transpose method. Third is ratio method. And finally, you have the Vinculum method. Under Vinculum method, you will not find it in any textbook or on any YouTube video. Remember, the divisor and the dividend both can be Vinculamized to get the same answer. You can try it yourself. All 16 sutras of Vedic mathematics can actually be applied to both multiplication and also to division. My objective here was to simplify and demystify, Vedic division. My objective was not here to get into these 16 sutras. The 16 sutras, some of them can be used in, equations of this type, x multiplied by x plus 1 multiplied by x plus 3 is equal to something, etc., etc. You can divide and use one of those sutras. So that was not my objective here. My objective basically was to showcase that quickly using the 4 methods, you can divide any kind of number by any kind of number. I hope everything is clear. Do you want me to run through the slides again slowly?
Yeah, sir.
Yes, sir.
Okay, great. So if you have any doubts, I can, we can still run through the presentation once more. This particular slide will give you a very good heads up display on everything. You just need to remember this. Remember, see, over here, just notice what I'm doing in my presentation. I'm not looking at the dividend at all. I'm not looking at the dividend at all. It's a divisor all the way. What is my divisor? Where it is? Is it close to any base? Does it have digits like 6, 7, 8, 9? Can I convert these digits into something? 67 in the world of Vinculum division is 3 bar, 7, 3 bar. Again, I have a 7, 3 bar, 10 minus 7 is a 3 bar. And because this is a 073, this becomes a 133 bar. I use this particular transpose method over here because my divisor begins with a 1. I drop this 1, I transpose 3 bar into positive 3, another 3 bar into positive 3. If I'm getting 79 as my divisor, let's Vinculamize it. 10 minus 9 bar, 8. This is effectively 081 bar. This is 1 bar. This is 2 bar. This is 1. I drop the 1. I transpose this -2 into +2 and 1 into 1. Is my life not a lot easier than dividing by 79? I've converted it into software easily handled. Right? And believe me, yesterday also, those of you who attended my class yesterday, I kept telling you that maths is very badly taught. The textbooks are horribly written, and the teachers who teach in schools, they just know anything. They don't know how to articulate out maths to the students. If you ask them, what do we do if we get a negative mantissa and we have to find out the antilog? You can't. You have to do a +1 and a bar 1 addition to the antilog, to the number with the characteristic and the mantissa. Basically, ideally, just follow these steps and you will never face any difficulty. Just look at the divisor, where it is, not close to any base. Can I scale them up? Yes, I can scale them. Can I do something with 425? Why not? If I multiply 425 by 2, I bring it closer to the base 1000, I get a number called 850. If I multiply 425 by 3, very easy, 25 3s are 75 and 3 4s are 12. Here I will use the Nikhilam method. Here, because I am getting a 1 in the beginning, I will use the transpose method. I'll drop the 1 and I'll get 2 bar, 7 bar and 5 bar as my